Ada beberapa yang namanya nggak ada sini.
Ada yang internetnya nggak baik paling Pak.
Iya, paling ada yang DC lagi.
Putus nyambung.
Ya. Oke, jumlahnya udah benar. Berarti yang tidak ada tinggal 2 tadi itu ya. Ada Hania sama Muhammad Ihsan. Oke, makasih. Oke. Oh, sorry. I forgot that. Sorry. I forgot that this is an English class. Yeah. So in the next times, if I ever use my Indonesian, please remind me, okay? Because for today's class, I'm class between 2 Indonesian classes. Yeah, the morning class and the noon class both are in Indonesian. So I instinctively used Indonesian. My bad. Okay, again, if I ever stumbled in Indonesian, please do remind me. Do not hesitate, okay? I won't share you out or anything. Thank you. Okay, thankfully Hania is here, so only Muhammad Ihsan is not here yet. Okay, let me update that attendance. Hello, Hania. You there?
Iya, Pak.
All right, thank you. Okay, so for today, we are going to continue our AI fundamental class. I'm going to start recording. Also, again, if I ever forgot to record, please do remind me, because if you miss out the recording, it's your loss, okay? All right. Resume recording, and now we are going to the slide for our week 2. You can get it also in ULS if you want. There's the uninformed search part 1. I really suggest you guys to download it now. Why? Because for today's class, we are going to have exercises which you will have to do in class. Again, you have to do in class, and this exercise will be turned in after the class ends. So please do download the slides to make sure that you have you can do the exercises later on. If you don't do the exercise, it's your loss. Okay? So for today, we are going to get into the new territory of uninformed search. Maybe for now, the name uninformed search doesn't ring any bell. What is it, sir? Yeah. It's fine. We are going to learn through it. Okay? Okay, thankfully Muhammad Ihsan came in the last minute. Hello, Muhammad Ihsan. Muhammad Ihsan, have you joined?
Hadir, Pak.
Okay. Yeah, you got lucky to get in the last minute. Okay, so for today's class, we are going to enter the territory of uninformed search. Because the title has part 1 in it, of course, there will be part 2, which is next week. Okay? So one big part of intelligence system is search. Yeah, someone or a machine is considered intelligent if he or she or it can find or search a solution faster than the other. As you can see, we may use it daily, but actually Google is a really handy and intelligent system. Like say, in the past, if you want to search about something, you really have to deal with everything else. Like say, if you want to search for a book, it's very hard to go. You must go to the library maybe, and then you may have to ask the librarian, I want to search for a book about this. Do you know anything about it? And so on. And even then, the result you get might differ times to time. Like say, at one time, you get the book you wanted. Another time, you only get something that remotely resembles something you want. So yeah, in the end, the things like Google really helps our lives because it's intelligent. It can search the solution faster than the others. When someone is searching without knowing what the goal is, it's called uninformed or blind search. So it is searching for something, but it doesn't really know where the goal is. It's searching blindly. That's why it's called blind search algorithm. Or in more advanced terms, it's called uninformed search. There are two commonly used blind search algorithms. There are brief first search and depth first search, BFS and DFS. DFS, as its name suggests, it prioritizes searching deeply first. It will search to the deepest part of something, and afterwards, it will try to broaden its horizon to its surroundings. While the opposite runs true for breadth first search, the BFS. For BFS, it will try to seek out every possible nearest solutions first. Then afterwards, it will go deeper a bit. It will go a bit deeper, then it will search for more solutions in that layer. So say we will try to see an example of the breadth first search and the depth first search. We are going to test the false coin problem. So in this problem, there are 12 coins, but one of them is fake, is false. The false coin is lighter or heavier than the original, so the weight will differ. If the original is say 1 kilogram, maybe the false coin is like 2 kilograms or half kilograms and so on. An ordinary balance scale can be used to determine if any two sets of coins weigh the same or not. So if the weight is not the same, you know that one of the coins is a false coin. Identify the false coin by maximum 4 times weighing. So if by 4 times weighing you can't find a coin, it is deemed not effective. So it's a basic example case where there are something that you should point out the difference on. So let's try to simplify the problem by using only 8 coins. It's a try to understand the problem. Okay, first, let me get my tablet first. Wait. For some reason, the Bluetooth is not connected. Let me pair it first. Okay, it's connected. Thank you for waiting. Let's get back to the slide. Okay, so first we have 8 coins from C1 to C8, right? And now we want to know which one is the fake coin. We want the false coin to be found in less than 4 wigging. Okay. First, you can, after this, you will get 10 minutes to try to complete the state space graph. So for now, prepare your paper. I will give you 5 minutes to prepare your paper. So make sure that you guys ready your paper and pen. Okay? Pencil we will do as long as I can see it later when you photo it. I'll give you 5 minutes to 10 past 10, okay? For now, the 5 minutes is to prepare your paper and your pen. Afterwards, I will show the example and then you will get another 10 minutes to do the exercise, so don't worry, okay? I assume you guys have prepared your papers and pen. So let's start from here. For some reason, there's no line in here. Wait, what? Okay. There should be a line here too. Okay. For now, we have 8 coins, right? Coin 1 through coin 8. And we want to seek one of the coins, whether it's false or not. We want to seek out the false coin. Which one is false, right? So first, we are going to weight 6 of them here. We are going to weight 6 of them from C1 to C6. First, we will see whether it's equal or not equal, like this. If C1, C2, C3 weight with C4, C5, C6, if it's equal, then it means that the fake coin should be, can anyone guess? Either, yes,
C8 or C7.
C7 or C8. Very nice. That's why this is the list of suspects. It's either C7 or C8. In this case, because we know that C1 through C6 is real, then we just need to compare one of them, like say C7, with one of the real coin, which is C1. If it's equal, it means that C7 is also real, right? Then it goes without saying that the false coin is C8. The same thing happens when the result is not the same. Because C1 is a real coin and C7 does not weigh the same with C1, it means that the false coin is C7. It's as easy as that. What happens when C1 to C6 is not the same? It's not equal. If they doesn't weigh equals, then it means that the fake one should be inside this group. Inside C1 through C6. One of them is the false coin. And by that logic, C7 and C8 should be real. That's why in the second step, you need to weigh again both of the real coins with 2 of the 6 coins. Whether it's equal or not equal. If it's equal, it means that C1 and C2 is real. That means the list of suspects are further thinned out into C3 to C6. Only 4 left. If it's not equal, it means that one of them is fake. That means the list of suspects is now C1 and C2. And from here, it's the same as this. Yeah, it's the same as this. You guys know which are the fake candidates? And then, based on that, you can compare one of them to one of the real coin. And then you can get the real coin and the fake coin. If it weighs the same, then it means something. If it doesn't weigh the same, it means something too. Any questions here?
No.
No? Okay. Then I will give you 10 minutes to complete this diagram. So please write from the start. From start. As start. Write it from start until the end. Until all goals are written. Okay? I'll give you 10 minutes until 10 and 25. Do it now, okay?
Where to submit?
No. No need to submit for now. Just do it for, I'm going to give you time for 10 minutes. Everything will be turned in the end of the class. Okay? So for now, just try to do the exercise in 10 minutes. Okay. All right. So if you guys haven't finished, you guys will have a bit of time to finish it in the end of the class. So make sure you guys finish it and later on turn in it in ULS. And and do not do it for now, okay? Because you should turn in every exercise in one place. So make sure that you guys turn it in the end of the class. I will create the post to submit the assignment in end of class too, okay? Okay. Then the second part is backtracking. So as shown in the first week before, there's a way to solve something from the goal. You have a goal, then check for possible solutions from there to your start. Each proposed solution is called a stage. If all possible solutions cannot be performed, then we return to the previous state. It's like something like this. It's a start, right? It's a start. And then first we go here. Okay, we go here. No problems? No, go here. No problems? Go. No problems? Go. Problem. This is wrong. Okay. Then return one step and try another path. No problem? Okay. No problem? Okay. No problem? Okay. Problem. Then return to the last branch and so on. And afterwards, if it hits another end, then it will go back to the first. And then maybe go from here and so on. It's like that. If there is no possible solution in a layer or a stage, you backtrack again until you can find a possible solution or until every possibility ends. It's like this, the 8 queens problems. The 8 queens problem, it needs you to place 8 queens on an 8 chessboard so that no 2 queens are attacking each other. You guys know how queens attack each other, right? First, it can attack horizontally. It can attack vertically. And it can attack diagonally. Like this. Oops. Well, it's wait. I meant this. Oop. Yeah. Please pardon my shaky diagonals. Sup, okay. Sup, and sup, like this. So we need to put 8 queens so that they won't hit each other. It may seem easy at start, but it's very hard because you must put 8 queens without hitting each other. For now, let's simplify the problem to 4 queens because we are still trying the basics of the problem, right? So first, we try from the bottommost left one. Here, this one. From here, it can attack like this, right? So, for now, the ones that you cannot use are here, 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 here. Like this. These are the zones that you cannot use if you use here. Then, because these two are unusable, so for the second queen, you want to try putting it here. It's safe, right? Yeah, it won't hit anything for now. Because of this, what happens is that these 3 cannot be used because of the second queen, right? Can we put something in 3-4? Can we put something in 3-4?
Oh,
No. Why?
from the 1-4.
Yes, it's from the 1-4 queen. The 1-4 queen can attack here. So this is not a possible solution. As you can see here, you can't put anything if you put the second queen in the 2-2. Okay, we're going to put the second queen in 2-1. Right? From here, it should attack here, here. So it cannot use here, cannot use here, cannot use here. So we can only put it here or here. But here, as you can see, we cannot put it again, right? So it's like this. Because of the queen in 1-4. So the only possible place to put is in 3-3, like this. What will happen if we put in 3-3? As you can see here, we cannot put anything in the 4th. This one will get killed by this. This one will get killed by this. This one will get killed by this. Will get killed by this. So, can we put it here, sir? No, we can't. Because it is also hit by the third queen in 3-3. Because of that, we backtrack for a bit. Okay, backtrack. It must mean that it's not here. It's not the best part for queen. Okay, we try the next one in 3-2. Can we put it here?
No.
No, because it's going to get attacked by the second queen. This one is also a no-no. That's why we are going to backtrack another step, like this. Because this is the last row, and we have already tried the other rows in the earlier steps, then we cannot use these two. We are going to backtrack again. And this time, because we've used the first one, we are going to use our second one, which is the 1-3. It's like that. And so on. Based on this, you can go forward and clean the board and put everything on board. Okay, for now, you have 10 minutes for exercise 2 to complete the state space graph for the queen's problems. So make sure that you write from the start, from here, until the end, where you can put 4 queens on table. Clear enough? Okay, for now you get 10 minutes until 10:45. Continue in the same paper, okay? If you run out of paper, you may use another paper. Thank you. Anything I can help with? Kevin?
No, it's hard to make all of the box. That's
It's
the most
hard
time-consuming
to.
one.
Can you repeat that? Can you repeat that?
No, it's just difficult to make all the box for the chest.
Oh yeah.
So it's the most
Just-
time-consuming one. So
Yeah, it's okay. Just create a box that as long as I can recognize the box, it's fine. Okay. I'm going to add 2 more minutes to 48, and after that, we are going to continue with the class. Thank you. Okay, that should be enough extra time, right? So let's get back to class. So for now, we are going to go to the next state spacecraft, the vacuum cleaner world. In this figure, there are 2 locations. squares A and B. The vacuum agent, which is this one, this perceives which square it is in and whether there is dirt in the square. It can move left, move right, or do nothing. And of course, if there's dirt in the place, in the square it is in, it will suck up the dirt. This is the main point of the logic. If the current square is dirty, then suck. Otherwise, move. Just like that. It's like your Alpro or maybe OOP, where based on the conditions, it will do different things. Okay, first, this is the example. What should a vacuum cleaner do in the world? First, it should notice whatever it is, like say dirt and robot location, where are the dirts, where are the robot, and so on. And then we are going to simplify the commands, the actions to left, right, and suck, L, R, and S. And the goal is to have no dirt at all locations. When everything is clean, then the goal is reached. So say it's like this. First, it starts in the in this region, right? In the left. In the right, it can either move to the right or suck. If the logic consists of sucking first, then it will suck. Afterwards, because there are no dirt left in this part, it will move to the right. Move to the right, like this. Because there is dirt in here, it will suck. Poof. And because it is clean, it's the end. The other way to do this is by moving right first. It will move right, then it will check whether there are dirt in its square. Oh, there is a dirt here. There is a dirt here. Okay, suck. It will suck the dirt, and poof, it will be gone. And then it will move to the left, move, and it will check whether there are dirts in here. Oh, there is a dirt here. Okay, then suck. Poof, clean. Because there are no dirt at all, it will end. Just like this. Any question for the vacuum cleaner logic? So the important parts is these three parts: the states, the actions, and the goal test. The states in here is where the dirts are and where the robot is. Then what actions can it do? It can go left, it can go right, or it can suck. And the goal is, of course, when there are no dirt at all, locations. Simple as that. The start state should have both rooms having dirt. And in the goal state, the goal is to have no dirt at all. So the solution is, for the start state, you can suck, and then go to the right, then you suck, then go to the left, and once it goes, it can check that, oh, there's no more dirts. So it's a goal state. It will end there. Like that. Okay. So we will try to revisit this question, this puzzle, the 15 puzzle. So in this 15 puzzle, we want to create this, right? We want to create a state where every every tile is in order from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, and then the blank spot. Because this is a bit of an advanced puzzle, we are going to try with the smaller one first, the 8 puzzle and the 3 puzzle, this one. Oh yeah, before I forget, for next week, for week 3, I think we are going to still have an online class because, as you know, COVID is still in the rise, and me myself is not really healthy enough because, as you can hear, I'm still coughing here and there. And even though I've tested it to not be COVID, it will make lots of people uncomfortable, of course, because of the coughing. So yeah, for now, until the 3rd week, we are going to go full online. Okay. Okay, for the 3 puzzle, be aware that the state space for solving the puzzle can become very large. What does it mean? When the puzzle is like this, the 15 puzzle, the possibilities are very big. You can go here, you can go here, you can go here, just like here. In this one particular state, there's the outcome where it goes to the top, it goes to the right, it goes to the left, or it goes to the bottom. Yeah. There are 4 possible futures from this one state. That's why it may make the state space graph ultra big. Be careful on that. The state space for 15 puzzle is 16 factorial, which is 2.9 with 13 zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0, that's still only 9. 0, 0, 0, 12, and then 1. So it's like this. 12, yes, like this. Consider the possibilities. It's just too big for a human brain to handle, right? A search from start state to a goal state probably will only need half of this number of states. So from all the possible states, we usually, in average, only need half the numbers. But even half the number is still big, right? It's like, what was it again? 1 point, like this. This is still a pretty big number, and it's not for human brain to do it. For example, if we are going to use DFS or depth first search for the following 3 puzzle, we want to be able to change from this start state into this goal state. How can we do it? First, using DFS, because we are using depth first search, we are going to check for every possible branches first. We are going to check inside every branches. Afterwards, if we hit a dead end, that's when we are going to return to the previous branch. We need to consider that the blank move, the blank part, this one, this blank one is the one moving. The order of movement should also be standardized. Like in this case, it will be up, down, right, and left. The search is planned, of course, but to simplify things, we will avoid repeated states. Because like say, if it's like here, if we move it upward like this and create something like this, there are totally no points to create a down move, right? That's why repeated states will be avoided. Forbidden move will also not generate state. Like say, in this blank state, in the start state, because the blank is in the bottom right, there are no way for it to move to the right or to the bottom. That's why in this kind of state, the only states available are either it's moving up or moving left, like this. Only two states. Yes, as you can see here, first, we have it here in the start, right? First, we are trying to move it to the up because the order is up, down, right, left. Okay, first, we are going to move it up, so the blank will be here, right? Then, because of this, first, we are going to try to move it up. It can't because it's in the topmost block. Then, the next order is going down because it's up, down, right, left, right, left. Down. It can produce a state, but it will be crossed out. Why? Because as it said before, avoid repeated states. So it's also crossed out. And right, you cannot go to the right, so crossed out too. So the only possible way is to go to the left, which will create this one. Then afterwards, we always will check this for, can it go up? No. So up is crossed out. Can it go down? Yes. If it go down, it will go to here. Then again in here, test things out like this. Can it go up? Yes, but it will repeat this one, right? So cancel it, cross out it. Then can it go down? No. Cancel it. Can it go right? Yes. This is the answer for now. Do these steps all the time until you reach the goal, like that. Any question for this tree puzzle? Nope. Okay.
Sorry.
Yes.
Why isn't the possibility of from the start position? Why can't the block go left?
Can you repeat? Sorry.
At the start position, why isn't the possibility of the block going left considered?
Yes. It is not considered. Again, it is not considered. But from the first time, we are already using this order, right? We promised ourselves to use this order: up, down, right, left. This one. And because of that, of course, we are checking things in order. First, we try going to the up. Okay, it's possible. Okay, then go up, like that. And then every step from the start to the finish, we just repeat this from the first. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, like that. That's why this is DFS, right? DFS means depth first search. So in actuality, there's another chance that something is here if it move left, right? That's what you're saying, right? But before we can continue to this possibility, we already reached the goal. That's why it's so.
Oh, so we will only go to left if only every possible solution in the left side of the tree is a dead end.
Yes, that's right. So if this one is not the correct answer and it is crossed out, it means there are no more possible solutions, right? Then we will go backtrack, just like the backtracking in the chess piece. Okay, let's backtrack. Are there any other options? No, backtrack, backtrack, backtrack. Until we run out of options, then when we backtrack to the first one, okay, we can move left. So it will produce the left one, like this. And then it will go and use this again to seek out possibilities, just like that. Clear enough?
Yeah, thank you, sir.
Yep, you're welcome. So the answer is because we already found the goal here. If by chance the goal is not seen and we cannot find the goal here, we will backtrack fully until we find a possible path, which might include this starting point. Other questions? No? All right. Wait. Let me drink a bit. My throat's hurting again. All right. Thank you very much. Next. This is quite a peculiar problem. Missionaries and cannibals. Our mission is to get 3 missionaries and 3 cannibals from the east bank to the west bank of a river with a raft, of course. The raft can hold no more than 2 people. And one thing to note, we need someone to be on the raft. Of course, without saying, without someone in the raft could not move left or right. Be wary of that, okay? The cannibals should not outnumber the number of missionaries, or the missionary will be eaten by the cannibals. Like say, if you put you put 1 missionary here, it will create a situation where in the east bank there are 2 missionaries and 3 cannibals, right? In this state, the 2 missionaries will die. So that's not a valid proof. How do you represent the knowledge of this problem? Yes. First, I'm going to show the starting steps. First, we have west bank and east bank, right? And reef position. Reef position is like this. It is west, it is east. If the raft, it's not rift, it's raft. If the raft is on the left, it's 0. If the raft is on the right, it's 1. Okay, starting. The available moves are these. 2 cannibals, missionary cannibal, missionary, or 2 missionaries. First, we are going to try. For the sake of simplicity, we are going to move with MC. You should just decide from where you want to start. Like say you want to start with 2C, C, MC, M, 2M, and so on. It's your choice because the graph will be quite big. For now, I'm starting the example with MC. 1 missionary and 1 cannibal, which brings the raft to the left side, to this one. This time, I transported 1 missionary and 1 cannibal to the left. Because it goes to the left, the next time, I should not do the MC move. Why? Because if I do the MC move once more, it will just return to the first state, right? That's why this state is crossed out. As always, we are not going to do steps where we already know the results, where we already passed it. Okay, next we go to the M option. In the M option, we are going to return 1 missionary to the right. This one is 1. Okay. Then, because of this, the number of missionary will go back to 3 in the east bank. Then, we might test things like say, if we send 2 missionaries to the left side, it is crossed out. Do you guys know why?
because the number of cannibals
In
and missionary
east
is bigger
where?
cannibals.
West or east?
On the east side.
Is
Yes. If we choose the two missionaries move, the cannibals on the east side will outnumber the missionaries. So it's a no-go. Cross it out. Then in MC, this is the same because doing MC will make you have one missionary and two cannibals in the west side. So cross it. If you move two cannibals, you can have three cannibals like this on the west side and three missionaries on the right side. For now, it's not game over yet, so you can continue. Or you can try other options like say 2C, C, and M. Just like that. Try to find the solution of missionaries and cannibals using the FS. Continue the suggested state space graph. Also, if you want, you can go from the start if you want, but do it on your own volition, okay? For exercise 3, it's going to be 15 minutes. It's going to be until 11:28, okay? Complete the DFS state space graph for the cannibal and missionaries problem. Try to seek the solution for this, where in the end, the goal result should be like this. 3 missionaries, 3 cannibals, 0 mercenaries, 0 cannibals, missionaries, not mercenary, missionary, and 0. This is the goal state. This is the start state. And this is the goal state. Okay, time to start. Train. All right, so someone asked, what is this? What is this? This is the raft. Yeah, not rift, raft position. This one. Yeah. If it's in the west bank, it's 0. If it's in the east bank, it's 1. Okay? Hope it helps. Okay, how was it? Any difficulties? Remember that for every option, there should be someone in the raft, okay? Make sure to not miss that. Yeah, you can just like, oh, we got, where was it again? My pen, oh, this one. Like say in this one, this, you cannot just change it to like 1M, 1C, 2M, 2C, and then 1. Yeah, the raft cannot move by itself. The raft cannot move through the river by itself. So every time it moves, there should be a change in the number of people. Okay? All right. Yes?
Sorry, sir.
Mm-hmm.
I can use my pattern, my own pattern.
You can use.
From start.
Oh yes, of course. Yeah, just list your patterns. Like say, sir, I want to do it like 2M, M, MC, C, 2C. It's fine. Okay.
Okay, sure. Thank you.
You're welcome. All right. The next, there will be a bit of time in the end to to finish things. So yeah, you can just finish it later on. But yeah, please make sure to do it because the time is not that long. Okay. Now we are going to move into implementing depth first search. The various search algorithms like depth first search, breadth first search usually use two lists, open list and closed list. Open lists are nodes or points in the tree that are not used yet, while closed lists are the nodes that are already explored or used. In depth first search, the search moves deeply into a search tree as quickly as possible. It means, yeah, as you can see here, newest added node is explode first. Newest first. Okay? Just remember this. Newest first. That's called DFS. In BFS, it's the later on in BFS, it's the reverse. It will be the oldest first. As oldest first, like this. In other words, it's last in, first out, LIFO. In BFS, it's named FIFO. Can you guess what is the F?
Was in first out?
Yes, the F is first. First in, first out. That's the BFS. Later, it's just a teaser for BFS later on. But for now, it's LIFO, which is the newest first. Okay. The DFS algorithm is like this. Yeah, you can read it in your own. But to simplify things, it's like this. If we got a node, something like this, sorry, let me do it like this. So if there are nodes like this, first we will start here, right? Then we will know, oh, there are this and this. Let's call it, if this is A, then call it B and C. So we got B and C in the list. First, we will explore B. Poof. From exploring B, we will get D and E. Like this. From B, we can get D and E. So it will be D, E, C. Then we will go explore D. We will find H and I. H, I, E, C. H is a dead end. I is a dead end. Then we will go E. E will get J and K. We will explore J. We will explore K. Then we will go back to C. In C, when we explore C, we will get F and G. We will explore F, and we will get L and M. L, M, G. Explore L, explore M, then return to G. From G, we will get N and O. Explore N and explore O. That's how DFS works. It tries to get deeper into the tree first. After it goes deep, it will go back. It will backtrace and then go to another path as much as possible. Then after it exhausts all options, it will go back and then try again, and then try again, and then go back like that. Any questions on DFS? Sorry, give me 5 minutes, okay? For now, try to understand this diagram, okay? Sorry, 5 minutes. All right, sorry for the wait. Okay, so as I've explained before, in this list, every time something is added to the list, it will be added to the front. Like I've exampled here, right? From here, we are going to start from A, right? This is a start. So for now, the first time, the open node is only A. When we decide to explore A and send it to the closed list, right? it will open the options available for A, which is B and C. Afterwards, we are going to explore the first node in here. Explore B. Poof, right? From B, it's possible to explore both D and E. So you will get these. Then explore D. From D, you can get I and J. Explore I, because this is the end, there's nothing. Explore G, because this is the end, there's nothing. Explore E then. From E, we can get 2, which is K and G. Explore K, as this is the end, it's a dead end, so K is here. K is here. And then explore G. Oh, G is the goal. We arrive in the goal. Okay, finished. So the solution is from A to B to E to G. This is a solution. Any question for now? Nope.
Sir, why is it G1?
Yeah, I think it's a typo. Yeah, it should be G. From my experience, I remember it's being G1 and G2 here. So yeah, do not mind the one. It might be a typo from the slide maker. It should be A, B, E, G. Okay. Yeah, it's now H, so don't worry about it. Any other question?
No, sir.
Okay. And for this, and because this is the last exercise, right? Yeah, this is the last exercise. So I'm going to just include it in your time to do things because yeah, you are going to need time to finish things, right? So trace the DFS algorithm, but this time the goal is N. This one, the goal is N. Start from A and finish at N. Okay. Do this like this, but while this one stops at G, continue to this path. Okay. For the exercise time, I will just include it in your after class work time. So don't worry about it. For now, the metrics for measuring a search algorithm are completeness, optimality. It should be optimality single L. Wait, single L. Oh God. Where does it? Okay, like this. Optimality, time complexity, and space complexity. Completeness is guarantee in finding the solution if a solution is available. If it's not complete, it may not find a solution, which makes it a bad algorithm. It should be complete if there is a solution. If it might not find a solution, it's a bad algorithm. And then optimality provides the lowest cost path among all solutions. How optimal it is? If it can always find the lowest cost path, it is optimal. An algorithm may not be optimal, but it's fine in most cases because case by case, depending on the case, some algorithm might be more optimal than others in specific cases. Then time complexity, how long it takes to find a solution. Yeah, you can use it. You can calculate it by using the number of nodes generated. The more node is generated and processed, of course, means it takes more time to find the solution. And then space complexity, how much memory is required to perform the search, can be determined by the maximum number of nodes stored in the memory. Like here, if you can see here, for now, the nodes stored are like this, right? These are the stored nodes. The more nodes needed to be stored, like here maybe KGC, X, Z, and so on. It means the more memory it needs, the more space it needs to save in memory. Okay, so for now, continue do exercise 1 and 4 for those who have not finished. And for those who have finished working, please collect your answer to your lecturer. And this notice is for offline classes. So because we are doing an online class, make sure after this, for those who have finished, please take photo of your paper from exercise 1 and 4, 1, 2, 4, I mean, and then upload it to ULS. I will create it now. Please wait 1 minute. All right, so I'm going to add an assignment week 2 assignment exercises, week 2 exercises 1 to 4. Yeah, ZB. Yeah, remember to submit it to class ZB. Okay, Alvin, can I help you?
Excuse me, sir. I want to ask for exercise 4, do we need to continue the list from G, or we could start from A to C to F and then finish with N?
Okay, so for the answer, you need to start with B, like the DFS before, because the rule here, the rule here is going from, I held my pen tab in reverse, sorry. The rule is go to left first, then to the right, like this, okay? So make sure to start from A, then because you are going to the left first, like this, right? A, then B and C, right? Because of this,
right.
Make sure you go to B first, D first, I first, like that. Clear enough?
Okay. Thank you, sir.
Yep, no, you're welcome. Because by default, when you use a tree like this, you will put things like this, right? When you close A, you get B and C, and when you put it on the list, it will be like this, B and C, which will of course make B be the first one to be checked. Okay.
Okay, sir.
Okay. For now, the deadline is, write this, on 1 p.m. 1 p.m. in Western Indonesian time. Okay. So you guys still got like 1 hour and 10 minutes to finish exercise 1 to 4. And again, this is a hard deadline, so be careful. If you miss the deadline, you won't be able to submit your assignment. And again, as I've said before, if you miss the deadline, I won't be able to help you, whatever you say, whether your internet is disconnected and so on and so on. The time is already abundant. You guys already got lots of time, okay? So please do this and then submit it as soon as possible. At the last time, the deadline will be in 1 p.m. Okay? Any questions before I close this class? Yes, Gede Dharma?
Excuse me, sir, I want to ask about...
Sorry, your voice is echoing again. Sorry.
Okay. How about this?
Much better.
Okay, I want to ask about the third question.
The third exercise, you mean?
Yes.
Mm-hmm.
Should
This
we,
one, yes?
Yes.
Mhm.
Should we write the wrong path on our paper, sir?
You can if you want. Like say, if you decide to do it like this, the 2M, wait, let me. If you decide to do it like this, you can just show that, oh, the 2M is bad. The M is bad. The MC is good, like that. Okay?
Okay. And in earlier, you write the order of the moves, like to C to, and then C, then MC, etc. And
Mm-hmm.
should we have to do it in order like that? Because in the PowerPoint here, the
Yes.
first one is MC, the second one is MC again.
Yes.
The second one is
Yeah, actually, the best move for this is to do it in order like this. If you have decided on order like this one, right? If you decide already up, down, right, left, you should continue up, down, right, left. But for some reason in this example, things are not like that. But I really advise you to do it like this. Why? Because this avoids you going down the wrong path. This is the better way to do it. If you want to do it like this, I can't really blame you if you guys do it like this, because the PowerPoint show is like this. But for me personally, I really think that if you do it like this, you will avoid unnecessary movements. And that will help you go to the goal sooner. So if you want to ask, can we do it like the PowerPoint? Yeah, you can. You can. But I really suggest you do it like this. Okay?
Okay, thank you, sir.
You're welcome. Any other questions? Yes, Kevin?
Excuse me, sir. Is there a certain
Yes?
format of our answers, like PNG or PDF?
Okay, nice question. So for the files, please pay attention for this. Make sure that the file names are NRP, name, week, number. For the format, use either JPEG, or PNG. Okay. If it does prove to be too big, you can use PDF in case your phone's resolution is too big. It's fine to use PDF, but it is preferred for you to use JPEG or PNG. Okay.
Okay, thank you, sir.
Yes, and for this number, you can use like a 1, or maybe 2, maybe 3, or maybe 1A, 1B, and so on, as you need. Yeah, just make sure that I can know it's your work from your name and from your NRP, from your student ID. Okay, Marcella.
So if we have like more than one paper, so we can just PDF it.
Sorry, can you repeat it?
I work on this on like 2 papers.
Yeah. If you have 2 papers, it's okay to do it like that. Like say NRP 1, 2, 3, Marcella, and then week 2, right? And then
Yes.
1, it's the first. Then for the second paper, you can take another picture and number it 2. For the third picture, you can just go like this. Clear enough?
And then we attempt
If you want to,
ULS,
if you want to,
more than one
yes,
photo,
yes,
more than one photos.
yes, it's fine. If you want to zip it, it's also fine. If you want to PDF it, it's also fine. The most important thing is that I can check your work. Plus, I know whose work it is. Okay? That's why,
Oh, sir. Thank you, sir.
yes, this part and this part is important. For the format, you can use JPEG, PNG, PDF. you can just PDF everything to one file, or maybe you can zip everything to one file, or you want to submit separate files, everything is fine. As long as I can know whose work is it and what exercise it is. Okay? Okay, other questions? Yes, Yuven?
Yeah, sorry, sir. Please go back to missionary and cannibal, the FS itu.
Yes.
I want to ask about for the first step yang start itu, yang at start. For the first step, then it will branch one by one with available move, or for the next step, follow the
We are using the FS, right? So first, it's going to move to one branch first. It will go deeper inside one branch until it gets blocked. When every move is blocked, then go backtrack until the available move. Okay?
Okay, so the first step at start, do not branch one by one at the available move.
Yes, for the first, you just move in your first choice. Like say, if you use this, the 2C, C, MC, M, and 2M, then the first move you got to try is 2C. And then if everything else fails, you try C, and so on. Okay?
Okay, then the C from step start.
Yes. So you try this, and then try any options in this. If you find one available option, go to the next level. Wait, I'll just erase. Okay. So first, from the start, if you get one available move, then go to the next node. You don't have to explore the other moves for now. Okay. Then when you found the second layer, you can try various moves until you find a available move. Oh, I found the M1 available. Okay, I go this. I go here. And then you just need to try to find another available move. Oh, this is available. Okay, I go here. And so on. If by some chance everything is blocked, you can go back here. If there are any options left, you can try two. If no option left, then go back here, backtrack, try other options. If there are no other options too, then go back to the first and you can try other paths like that. Okay?
Okay, thank you, sir.
Yep. One thing to remember, for the first move, you can only use 2C, MC, or 2M. Can anyone guess why?
Because it's not possible to do the other moves.
Yes, because if not, one easy point to say it is that the RAF will not be able to go back. Like say, if it's east and west, and it's like this, 6 people is here, and the RAF is here. If you send only one people here, sure. Okay, one people is here. Then who will bring back the RAF to the east side? Right? Because there's no one, you had to ask this person to go back to the RAF and go back to the east. In the end result will be like this: 6 on the right and 0 on the left, which is moot point. So for first move, you can't use C or M. Just reminding that, because you need someone to control the RAF. Yeah, you need this someone to control the RAF. Okay, more questions?
Excuse me, sir.
Yes?
So I wrote my number 1 and number 2 in the same side in my paper. So should I take my picture? Should I take picture one by one or what?
Up to you. If you want to take it one by one, then you can take number 1 and then number 2. It's fine. If you want to take both and then put 1 and then like this here, 1 and then underscore 2, it's fine too. Okay?
Oh, okay. Thank you, sir.
Yep. Again, The most important part is that I can check beware. Do not let this happen. Okay? Other questions? Nope. Okay. You guys have like 1 hour, almost 1 hour to finish the exercise. And as you can see in ULS, the exercise space is already put here for the class ZB. So make sure you do it on time and no late submissions. 13 at 13 is deadline, hard deadline. No extensions and no emailing or chatting me, sir. Can I submit it late? Sorry, I'm late, and so on. The time is, there are lots of time. There are lots of time to do it. Okay. All right. Thank you, everyone. I'm going to close the class. If